Um, Hello, esteemed colleagues and fellow nerds from academic realm. Welcome to my little corner of virtual conference stage. I'm Jesu Immanuvel. I go by Marcus. I'm from Richmond, Virginia. I'm here to talk about securing telehealth platforms. Okay, spoiler alert, it involves machine learning, DevOps, and a culinary themed plugin. We named it as Phish Chips, just after a pun, because who said healthcare security cannot have a sense of humor? Buckle up, we are going to dive into a world of phishing meets its match. Okay, telehealth is actually soaring. Post-COVID, 87% of US hospitals offer virtual consult, which makes them as virtual superheroes after that COVID era. But with great power comes great phishing attacks. That is a paradox. Telehealth is a lifesaver, literally, but it is also a hacker's dream buffet. Imagine your 80-year-old grandmother is trying to get her prescription filled, and instead of connecting with her doctor, she is accidentally giving all her information to a hacker who is who is there in the basement wearing a pajamas eating cold pizzas. That is not exactly the healthcare telehealth revolution that we promised, right? On a serious note, this is not a joke. It is a $10.93 million breach problem that is threatening our entire healthcare system. It's just not just in the United States, but across the world. I mentioned the healthcare is a hacker's dream buffet. Since 2020, phishing attacks jumped 189%, because who is easier to trick than your sweet old grandma trying to get her prescription filled online? Okay, the traditional security, network security, and the protection are like bringing a spoon to a gunfight. Okay, it's definitely time to upgrade our solutions with evolving AI-powered phishing scams. Okay, phishing is not just a nuisance; it's a healthcare's public enemy number one. Around 40% of the breaches in healthcare are phishing-related emails. I already mentioned it costing around 10.93 million per pop to do all of that. Which is enough. The 10.93 is enough to buy a private island. Okay, it's more than 93% of this is a social engineering or phishing. There are multiple forms of phishing, like spear phishing, hook phishing. The latest trend is smishing, like phishing through SMS. People in the United States might be really familiar in recent days about the unpaid toll-related SMS scams. So yeah, these kind of ransomware hackers are basically an uninvited guest for your healthcare party. So when it comes to cybersecurity, there are three musketeers in the ring. There are three traditional defenses, but like a block list. For example, block list, it's like your nosy neighbor, which is very good for known threats, but falter against new threats. Okay, the heuristic approach is really good. It's like having a protective buddy who loves customizing security solutions, but sees everything as a threat, which means it produces lots of false negatives. And the last one, AML method, is kind of a genius method. Like it's having a genius solution, but it is sharp. It does its job. It is achieving high accuracy and everything, but it requires lots of brain food to process. Like it needs quality data and it needs plenty of resources. It's like having a super smart pet, but that just he eats a gourmet gibble every meal. But in the end, every approach has its own quirks, proving that the world of cybersecurity has a room for everyone, every character. Okay, so what is our approach? Okay, what is this paper discusses? Okay, we propose one hybrid ML model approach. Okay, there's a really basic random forest and XGBoost. The reason why I say basic is these are traditional algorithms. It's a well-known algorithms used in machine learning language. It's not really complex, but it produces like 93% of accuracy with detecting phishing URLs. And with this approach, we integrated DevSecOps. DevSecOps includes a security into CI/CD pipelines and real-time updates. We can automate the testing also, like static application security testing and dynamic application security testing, things like that. And this solution offers a real-time protection shield. Whenever the user clicks on a link or enters the URL in the browser, the phishing shield will start to work right away. Just like the Phish Chips browser plugin, it is not necessary that this solution has to be as a form of browser plugin. It can be standard on application. It can made into a add-on to Outlook, add-on to our favorite mail client, things like that. It can be done. There are multiple avenues and multiple solutions that can be deployed with this. And also it uses behavioral analysis, which performs better than static rules. That are currently being used across multiple organizations and multiple tools that are already available to fight the phishing threats. Okay. We already talked a little about the three traditional methods, like a block list is a good for known threats. Heuristic approach is good, except for multiple false alarm. AML is genius idea, but it requires lots of computational resources, things like that. This method uses a hybrid model. So whenever user clicks or enters the URL in the browser, it will check the URL. It will check the URL, and if the URL is present in the existing data set, like in OpenFish or a Fish Tank website, then if there is any match found, then it will stop it right away. If there is no match found in the existing data set, it will check in the trained ML predictive model. The ML predictive model will give a probability of, based on that URL, we will be extracting multiple features. We will get to that in a minute. We'll extract multiple features, and it will give you the probability of that URL being a phishing website or not. Okay, based on that, whether it will be decided whether it's a legitimate or a phishing website. Okay, as you can see in the model, the accuracy and the precision recall, all the metrics are provided here. We will discuss the data set, the features used, the machine learning model, emphasis, everything in the next slide. However, we use two models after testing 10 different algorithms. These two random Forest XGBoost outperformed the other traditional ML algorithms. So we use them both in our model and create an ensemble stacked on each other. Okay, as you can see the performance there. We'll get to that training part. The feature engineering involves these many features. Before that, I will talk about the data set that we have used. Okay, the data set we have used is from UCI machine learning repo, PHI USA IL data set. It has around 134 legitimate URLs and 100K phishing URLs. It's a good combination and moderately balanced data set, specifically for this old algorithms. Our model doesn't just use one or two features. We have identified like 8 key features that can be used, like HTTPS status, subdomain count, URL length, URL shortening, special number of special characters presence, domain reputation, trusted site indicators like Google index, website traffic information, and IP addresses presence. Okay, it is like a digital DNA test for the websites. We are not just checking if you look suspicious. We are checking your entire genetic code for sketchiness. Okay, but this is just for POC purposes. But for more accurate prediction, we can extract, train, use 30 different features just from the URL alone. All those possible 30 features are provided in the appendix section of the paper. 10 different algorithms are evaluated for accuracy and performance. The emphasis was more on measuring metrics critical for healthcare platforms. Okay, like a recall to avoid any missed threats and false positive rate to prevent any care disruptions. Okay, we keep talking about browser plugin because it's already implemented and it's a working solution. So it is not necessary that this framework can be used only as a form of plugin. This solution, whatever we are offering in this paper, can be made into integrated into email clients like Outlook add-on to flag phishing attempt emails, or similar add-ons can be created for Gmail or other popular email providers. And we can create a mobile application, a telehealth mobile application specific ones and desktop applications, and available through APIs, allowing other systems to leverage the phishing detection services to enhance security. And existing patient portals can be integrated with this one to monitor user activity and warn of any new threats. And customer relationship management tools can be integrated also. And it's deployed in real-time monitoring system. So visual alerts and data analytics can be obtained from this one. Okay, so getting into this case study, and I don't have a demo for this one, but there is the version of the code and on one demo is available in YouTube. Those links are provided already in the white paper. But this already being used in one of the hospitals, and where we tested, it is already functioning fine. So will this really phishing detection system, and it is actually works. We just tested in the real world healthcare environment. The results are better than doctor finding a vein in the first attempt. Okay, here is how it goes down. First, the automated model training. It's like a fitness regimen. Our model gets a daily dose of training using the fresh phishing data from the sources like Fish Tank and OpenFish. And we have the browser plugin deployment. It's like an immune system booster for your telehealth portals and the system that you're using. It keep on constantly scanning for phishing attempts before they can try to get in, actually. Okay, so every detected threat is not just blocked and forgotten. That's what it's currently, all of the tools are being, all of the commercially available tools are currently doing. It will just block and it will stop right there. But this one, it triggers an incident response, generating a Jira ticket and integrating seamlessly with the CI/CD pipeline. Okay, so with a Jira ticket, you can continuously follow, you can add it, you can evolve. Just like the threats are evolving, the process, this application will also evolve. This framework will also evolve, it will learn, and it will continue to improve itself for the newer threats that are coming in this way. Okay, it's like think of like a self-improving security system that gets sharper, faster, meaner with every phishing attempt it encounters. Okay, this is like AI meets DevOps meets cybercrime nightmare kind of thing. Okay, so if you're wondering, cool, but what is the engine that it is running with? Machine learning algorithms, machine learning frameworks, all of them are Skylit Learn, NumPy, and Panda. API backend is Flash, and the browser extension we have created with JavaScript and the Manifest V2, because Manifest V3 is not supported in Firefox. So we don't want to leave that left out. And GitHub Actions for CI/CD, PyTest for making sure that things doesn't break, OpenShift for scalability. Okay, so it's a well choreographed ballet. Except for dancers, we have APIs, microservice, machine learning, and everything dancing around the cyber threats. Okay, so the browser plugin, how does it work? Okay, let's talk about the real world performance. Our plugin doesn't just detect the phishing attempts; it adjusts the feature importance dynamically. Okay, so it will adjust the feature dynamically as it trains and as it builds. Okay, and it let you customize the prediction probability also. Like if you want to have a strict threshold, you can reduce the threshold, increase the threshold so much so that even the small warnings will not get through. Okay, and it achieves like 93% in real time accuracy. Okay, it is not like model performance accuracy; it is near 93% real time performance accuracy, and it seamlessly integrates with some DevOps pipeline, so you can have a continuous feedback loop to do that. Okay, the best of all, the model training is not set in stone. Okay, you can tweak, customize, optimize to fit the evolving cyber threats. I told you we have used Random Forest and XGBoost. Instead of that, we can use complex algorithms like CNN or any other neural network also, and just replace the model in this entire pipeline. And you can continue using the tool as it is. So yeah, and as I mentioned, I don't have a demo plan, but I can show you a couple of screenshots of the working tool. It's a skeleton code. As you can see, I'm trying to access on the left-hand side, I have the browser window. On the right-hand side, I can see the response that the plugin gives. You can see the plugin here with a green tick mark on it. I'm trying to access U2. When it's a legitimate site, the probability is less. The prediction it says legitimate. Okay, it's a legitimate site, so the probability of it being a phishing site is less. So it will allow you to go through. And second one, it's also a legitimate site, Wikipedia. So the plugin turns green. It's allow you to go through. The probability is still less. And the third one, I'm trying to enter into an actual phishing site. You can see the probability is really high. It's a 96% probability that is a possibility of a phishing site. So it is redirecting it to a safety page. Like, do you still want to proceed further? I'm thinking that this is a phishing site. So do you want to proceed further? Something like that. So you can, in real time, you can see what is that probability, what are the features that are extracted, and how much probability that is being predicted, things like that is being sent under live. Okay. This slide just shows the screenshot of all the 10 models that were trained and compared, like random forest decision tree. There are all the 10 models, 10 real world models are compared. We didn't explore much with CNN yet. There was not much need because the random forest and XGBoost performed highly extensively good, and we stacked them together to improve the accuracy. So we combined them together to improve the accuracy. Okay, now next on to that DevOps integrated phishing detection system, the security, but it makes it continuous. Okay. Traditional security methods in CI/CD pipeline, they are decent, but they lack healthcare specific context, because healthcare, we have so much complex data and we have so much complaints to adhere to. So first, the pre-commit scans that catches the suspicious code before it even to get into, and the real-time monitoring, like constant surveillance for sneaky cyber shenanigans, and automated retraining. Okay, the model gets smarter every day. Unlike how the house plans, the model gets smarter, sharper, meaner every single day. The goal: build a system that is not reactive but proactive, stops phishing attacks before they cause any damage. Okay, like this will evolve, it will learn and evolve, just like the threats that are continuously evolving. And the real-time healthcare analytics for phishing prevention. Now let's spice things up with some real-time analytics. Okay, Kafka-driven data streaming, because real-time threats, you need real-time responses. Behavioral health analytics, think of it like a cyber polygraph test. Now for detecting anomalies in user activities, you will be able to catch malicious actor if there are anything inside, but it's already there, things like that. Okay, like and electronic health record integration for anomaly and threat detection. If the hackers are trying to manipulate the EHR records, like electronic health records, we want to know before they get away with it. Okay, so this is how cybersecurity meets healthcare analytics, where AI not only defends but predicts, alerts, trains itself for future attacks. And just as a conclusion, what is the takeaway? Machine learning and DevOps provide scalable and adaptive defense. We are predicting them. We are not just reacting, and we are just threat intel. We are just preparing for anything that comes in our way in future. Predictive threat intelligence is the way forward, and smarter ML and industry-wide threat sharing and the scalable security frameworks. Like we have to form a coalition with our industry peers to have the known industry threats and keep everyone informed, to have a scalable security framework that will help us solve these issues, to take the fight to the cyber criminals. That is the future of security, and that's the future of preventing everyone from the phishing attacks. Okay. That concludes my presentation.